Here's a little bit more on this schedule problem. Let me just give you the basic idea of what's going on here when you're computing or when you're looking at the forward pass as compared to the backward pass. So what has been established here are all the activities that need to be completed to complete the project and how the activities are related in terms of predecessors, meaning what activities have to be complete before I can start another. And then, of course, each activity has its own duration. So the idea first is we'll start at activity A and we will go through and compute the earliest time that each activity can finish. And in the course of taking this approach, what we're going to do is we're going to see how long does the project actually take. And in this case, this project is going to take 68 days based on the activities, the relationships, and the activity time. Once we do that, we're going to then compute the backward pass to say not how early can each activity finish, but how late can each activity finish. And those activities that have the same finish time, early finish time and late finish time, will be the activities that have no slack, meaning if those activities are extended for any purpose, then you have extended the duration of the project. And obviously, in this world, you do not want to extend the duration of your project. And those would be the activities that are on the critical path. So going down through the forward pass is easy. I think where everybody struggles is on the backward pass, but we'll talk about that in a second. Let me just talk about the basic analytical approach here. We start at activity A. It has no predecessors, so it starts at time 0. The activity duration is 3 days, so it finishes on day 3. Activity B, same idea. It has no predecessors. It has an activity time of 3 days, so it can start at time 0 and it will finish on day 3. Then we look at activity C, and what do we see? Well, activity C cannot start until activity A is done. So what I want to do is understand when does activity A finish, and it finishes on day 3. So we will say that activity C starts on day 3. It has a 7-day duration, and so it finishes on day 10. Same idea for D. Since it has A as a predecessor, it will start on day 3, 10-day duration, so it finishes on day 13. So this situation where you only have a single predecessor is very simple. You can look at the math. It's quite simple. The challenge on the forward pass comes in when you have an activity that has multiple predecessors. And so this is saying that activity I cannot start until both activity B and activity H are finished. So what we need to do is we need to go look at when activity B finishes. Activity B finishes on day 3. Activity H finishes on day 50. So because both of these activities, both B and H, have to be complete before I can start, I cannot start until day 50. And with a 15-day duration, it will end on day 65. So the math on the forward pass is very simple. You have 2 activities with multiple predecessors. And again, what you're going to do is, what I just discussed here. You need to look at the early finish times for both, take the largest of the early finish times, and that becomes the early start time for the activity with multiple predecessors. Excuse me. And the key here on the forward pass, again, is finding the duration of the project. And note, it may or may not be your last activity. That's not a big deal. Just note that the duration of the project is day 68. So now what we've got to do is we've got to kind of reverse our thinking here when we look at the backward pass, because we're going to start at the late finish time of our last activity, which is activity W. And so since the project is going to take 68 days, the backward pass assumes that activity W can finish on day 68. And since it is the last activity in the project, what I'm going to do is simply subtract the activity time of 5 days. So W can finish on day 68. It must start on day 63. Then I'm going to look at activity V. And what I'm doing on the backward pass is I'm taking this activity and then I'm looking backwards to see if activity V is a predecessor for any activities that come after it. And I see that only activities G and P are predecessors for activity W. So activity V can also finish on day 68. If I subtract the project or the activity time of 3 days, it can start on day 65. Then I do the same for activity U. And notice that U is not a predecessor of V or W. So it can finish on day 68. If I subtract the 5-day activity time, it starts on day 63. Activity T, same thing. Notice it is not a predecessor of U, V, or W. So 68 is the finish time. 67 is the start time because of a 1-day duration. Activity S, notice the same thing. It is not a predecessor, so it can finish on day 68. I subtract the 3-day activity time and it starts on day 65. Activity R is the same thing. So we have this for R and Q. So all of these activities can finish on day 68 because none of them are predecessors for activities that come after them. Where the challenge comes in here, or where the first point of interest comes in, is activity P, because notice that activity P is a predecessor of activity R. Let me just highlight these so we don't lose track of them. Activity R, activity U, and activity V, and activity W. And so to establish the late finish time for activity P, what I'm looking at is the earliest of the start times for activities R, U, V, and W. So our activity R starts on day 67. Activity U starts on day 63. Activity V starts on day 65. And activity W starts on day 63. So in order to keep the peace here, in order for activity P to act as its predecessor, it must finish on day 63. Because again, it has to finish before U and W can start. So day 63 is the late finish time for activity P. I subtract the 30-day activity time, and it starts on day 33. So let me undo, actually, let me see if I can just do this, there we go. So on the backward pass, that is the key analytical piece. And so I think if you look at activities Q through W, the late finish time of day 68 makes sense. Again, where this becomes a little more challenging on the backward pass is understanding that P is a predecessor for 4 activities that follow it. So it must be finished before these others start. So at this point, I think what's important is that you just consider the analytical approach on the backward pass as compared to the analytical approach on the forward pass, and make sure you understand why we distinguish the two. Just one more idea here. Since activity O is a predecessor of activity T, and activity T must start on day 67, then activity O must finish on day 67. And then we subtract the 3-day activity duration. So activity O starts on day 64, ends on day 67. I don't think M and N are a problem. L, let's just do one more of these, and then I think we can bring this to conclusion. Notice that activity L is a predecessor of activity L. And activity L must start on day 33, so activity L must finish. Let me make sure I said this correctly. I don't want to make sure I get my letters crossed up here. Activity L is a predecessor of activity P. Activity P must start on day 33, so activity L must finish on day 33. I think I got my P's and L's mixed up there for a second. So if activity L must finish on day 33, it must start on day 28 since it has a 5-day activity time. And so again, I think on the backward pass, the only thing that you have to be concerned about is looking at the activities that are predecessors for multiple activities that come behind it. Let me just see if I can find one more here. I think there is one more. I think it is H. So activity H, let me just highlight these and just make this point one more time since we got multiple predecessors here. So H, one more time here. Okay, so activity H is a predecessor for activity I, activity K, activity N, and activity O. So what I'm looking at here is I'm looking to find the earliest late finish time for these activities, and that's going to become the late finish time for activity H. So I look at activity I, which must start on day 50, K must start on 58, N must start on 65, and O must start on 64. So I think the smallest here, or the earliest, was day 50. So that becomes the late finish time for activity H, day 50. I subtract the 40-day duration, and then that tells me that activity H must start on day 10. So if you go through this and your math is correct in both directions, you should have an early finish time of day 68. And then what you should find on the backward pass is that activities A, C, H, I, and Q have no slack. So that is the critical path. Hope this helps.